Okay, so we looked at calculus as a starting point. So we've said that differentiating an expression finds what? Tells us about the gradient. Okay, so if we needed to find the gradient of a specific point at a certain value of x, we would differentiate it. If we wanted to know when the gradient when x was 7, for example, we would then, with that derivative, we would substitute the value in. Yeah, so we've done all of those types of things up until this point. Now, this is another kind of question that you might get. They talk about turning points. These are also called maximum and minimum points. What else are they called? Stationary points. So turning points, stationary points, and you're pretty much only looking at maximums and minimums. Okay, so if you see a phrase that talks about stationary or turning, that's what we're going to do at this point here. Now, maximum points look like that. Where have we seen maximum points before? Parabolas, yeah. Parabolas were what kinds of graphs? Quadratic graphs, yes. Awesome. Minimum points. But like that. Okay? So maximum points would be this peak part here. The minimum point would be this part here. They also have points of inflection. Sometimes it's spelt with an X. Oh gosh, that's so not a point of inflection. They are cubics, yes. So these are points of inflection. Now we're going to focus on the maximum and minimums. Because I don't think you need to do the points of inflection. Now, remember we were saying that the gradient changes as the graph changes. So if I were to look at the gradient here, it would be steep, positive, and then it gets less steep, less steep. What's actually happening at this point here? What do you think is special about the gradient there? It's horizontal. So it means that the gradient is what? 0. Awesome. Yes, you'll see that? And similar thing here, the gradient is 0. And funny enough, it says here, these would all have a gradient of 0, i.e., divide again. Divide again would be equal to 0. So the kind of question that they might have is find when the gradient is 0, or find where the maximum or minimum point is, or find where the stationary values occur. So all of those expressions, what we would do is we would differentiate the expression, and then you would equate this to 0, and you would solve it. So to find where stationary values occur, or maximums or minimums occur, you differentiate. You equate this to 0, so whatever your expression is, you're going to put it equal to 0, and then you're going to solve to find the x value or values. Now, sometimes you may just have one value. Sometimes you may have 2. I would imagine that you're not going to have any where you have 3, but they do happen. Okay? So that's what we're going to do for the next few examples. So it's value bracket S. So it could be value or values. Alright, so it says find the stationary point of fx equals to that. So what did we say we had to do first, Ida? Wake up, remember we're doing that. What do I do there? It's written just here.
Differentiate.
Differentiate. So how would I show that I'm differentiating this expression here? What do I write here to show that I've differentiated it?
Oh, that's
Okay, well not just fx, f dash x. Yes? I perhaps should have said, remember we need to look at the expression and determine if we need to rewrite anything. I don't have any square roots, I don't have any fractions, so I'm good to go with this one straight away. Yes? So do make sure that you're checking the expression before you start differentiating. So I had a look, I could see there was no fractions or roots. Now I know I can differentiate. So, Shayla, do you remember how to differentiate?
Is it 3x 2?
Yep.
Minus 6x minus 9. And then is that the one that becomes 0?
Yes. Okay. Do you remember my other tip was that if you were tempted to write plus 5, here you would, if that was there, you would then join these two terms. And remember what I said was if you differentiated it, you should never be joining terms together. So that should tell you that you've done something wrong. Okay, so don't write it in. I didn't do it, just make sure you did. Right. Okay, so we've got f dash x equals that. And then our second step is to equate this to 0. So we literally then write 0 equals 3x squared minus 6x minus 9. And we're going to solve this. Now, what kind of expression is this? What kind of equation is it? It's a quadratic equation, yes. Now, remember you have a couple of choices for solving quadratics. You can either factorize it, or you can use the quadratic formula. Okay? So they're your two options. Remember, your calculator does the hard work for you if you choose to use the quadratic formula. I'd actually like to see if we can factorize this, because hopefully you're looking at these thinking, oh look, there's a 3, there's a 6, and there's a 9. So all of these numbers are divisible by 3. So my first step, if I were to factorize it, would be to bring a factor, a common factor out if I can. That's a minus 3, by the way, not. So I've got 3 bracket x squared minus 2x minus 3. Remember, my 3 doesn't affect my factorizing, so the 3 stays there. But I know that because it's still a quadratic equation, I've still got 2 brackets. So I'm going to have x at the front of both of them. And then how do I decide what the other 2 numbers are? Emma?
You multiply this to you negative 2 and wait, no, it's the other way around. Okay. You multiply this to you negative 3.
Good. Remember that a comes before n. They add to give the middle and they multiply to give the end one. Multiply all times and equal at times. Alright, so we need to choose 2 numbers that multiply to give negative 3, and those same 2 numbers have to add to negative 2. What are those 2 numbers, Emily?
Negative 3 and positive 1.
Good, negative 3 and positive 1. Remember that all if you write those in the brackets doesn't matter, as long as you have the correct sign with it. And then, Kiara, what does that mean my 2 values are?
X equals 3 and or x equals 2.
Remember they're the opposite of the values in the brackets. Now, if the question had said find the x values where the stationary points occur, we're done, we're finished. Okay? This actually says find the stationary points. So that means that I need to find their partners. Okay, remember when we were solving simultaneous equations with linear and non-linear? We would have a quadratic and we would have x1, x2, and then we'd have to find y1 and y2. Okay, you remember that? Yeah. So it's the same kind of situation here. This is going to be x1, x2, so we're going to find their partners. So how, Casey, am I going to find their partners? If I know that my 2 values are 3 and negative 1. To what? Awesome. So we're going to sub these values into our original equation to find our values for x. Because remember that fx secretly means y. Okay? So to find y1, it it would be, oh, for goodness sake. What is it? 3 cubed, oh my god. 3 cubed, is it? I lost my equation. Minus 3 lots of 3 squared. Minus 9 lots of 3. And then for y2, it would be minus 1 cubed, take away 3 lots of negative 1 squared, minus 9 lots of negative 1, plus 5. And just chuck it in your caps using the brackets, and that will save you a lot of heartache if you're getting stuff wrong with your squaring and your cubing your negative numbers. So please make sure you put just a number in the bracket and then the power outside it, otherwise it will go horribly wrong. So which two values do we get?
The negative 1 one is
10.
the negative 3 one is negative 22.
Negative 22?
Yeah.
Alright, so if we wanted to summarize then, our coordinates would be 3, negative 22, and negative 1, 10. Okay? Pretty straightforward, yes? So we just differentiate, put that derivative equal to 0, and then solve it. So obviously, if you've made a mistake with your derivative, then you're going to get the wrong answers for the rest of it, but you should be getting some follow-through marks. Okay? Will you be asked to state the nature of them? I don't know if you will. If they start asking about the nature of them, I don't know if they do or not. I need to look at some examples. No. Basically, if they ask you to state the nature of them, they're saying, is it a maximum point, is it a minimum point? Okay, so that's what they're asking you to do. You have the benefit because you're all taking into the exam your graphics calculator. And so you can actually draw this function here. So you would type this into the y equals. And you would see that it does something like that. Okay? And so you would see that your first point you get to would be the maximum one. And the second one you would get to would be the minimum. Does that make sense? When I say first one you get to? Yes? So this first number here would be the maximum, this would be the minimum. And so looking at our two values for x, one of them was negative 1 and the other one was 3. And so it means that this first one would be when x was negative 1, and this second one would be where x was 3. So you would say that this value, this coordinate here was our maximum, and then this one was our minimum. Does that make sense? No, I lost you? Yeah.
Why is the lower one 3 and the higher one exactly?
So, because if I were to draw this on an axis, a set of axes, I don't really care if my numbers are right. Oh, okay. This value here, this one here, must be the lowest value of x that we got. So we got two values for x to live with. We got a negative 1 and a 3. Yeah.
Sorry, for x, not y.
So the x is our x values, which means that in the order of it, it has to be that this one here must be where x is negative 1. Because the way we label our axes, it's our negative numbers and our positive numbers going up. And this one has to be when x is 3.
No.
No?
Because it's not the y-axis, it's the x-axis.
I don't care how high up it goes or how low down it goes. On my set of axes, the x coordinate, the x value.
Lower.
No, the x value, the x. Remember, x is a horizontal number. So if I was to plot the point negative 110, I'd have to be in my negative section and go up to 10. So my negative 110 is not going to be before this one. Yeah? Okay. On it. I'll talk to you about more if you're the only one. Okay? So maybe done by sketching the graph and identifying the appropriate points. Okay, well, so let's do this one like that. So here's negative x cubed minus 2x plus 5. Now, I've said here, you know it's a negative cubic graph, but we haven't really talked about negative cubic graphs, have we? So ignore that statement, but let's chuck that into our calcs. So those of you with your graphical calculators, can you chuck it in? So it'll be good practice for you. And do not have a page.
No,
Oh, it's way down the page.
oh, yeah.
Just too many.
Wait,
There's still not a bad page. Which room? This bit?
Yeah.
Oh. Where did I get mine from? Where did I print yours from? So on the top left is a white, well yours is on the top left white, and then you literally type negative into this. And then your X button is your, that button, and then to the power is this button, the hat. On the left. Alright, hang on a second. So, your graph should kind of look like this. Yeah, so it should come down first and up then down. Which means that the lower value of x you get this time would be your minimum point. So, for example, if you found that your, and if you found that your two telling points were at 1 and x was 7, it would mean that this one would be the minimum point this time, and then this one would be the maximum. Because remember, we're looking at how far across, on the x-axis.
Why is it considered the
It's, that's a very good question. It's normally called like a local minimum. It's not the smallest value of the function. It's just called a minimum point because it drops down to a minimum. I don't know why they call it that.
It's because it's in the speed, like
Because it goes down, like so it goes low.
in between like this. Oh, I get it.
If you like, So if you've ever got a bit where a graph comes down and then goes back up again, so that would be a bit of minimum. Yeah. Okay, we're happy with that? I'm just going to stick with that, to be honest. I'm not going to go through any other fancy way. So we can ignore any other methods. All right? Because I don't think it comes up very often, so I don't want to. All right. Okay. So let's